Reading structural drawings is something that many students have difficulty with. I find it difficult to teach the topic because as a structural engineer, it comes very natural to me. So this video will provide a little insight into how I, as a structural engineer, go through a set of drawings. What we're looking at here is the first page of a set of structural drawings for a cultural center on the campus of Northern Arizona University. And I'm going to walk through the way that I look at this set of drawings. The first page here, you can see, starts with general notes. It's very common for structural drawings. And the first thing I do is page through the drawings just to see how things are organized and look for things that help me understand how the building is put together. So I start at the very largest level. I'll see the second page here. We can see that it's a set of typical details. Typical details are kind of boilerplate. They're nothing special. They're just the way many of the parts of the building are put together in similar fashion to other buildings. We'll see later a lot of specific details that were created just for this job. Another set of typical details. Usually the next thing we see are plans. So I open this one up and I can see a floor plan. We can see down here this is a foundation plan. The plans tend to go in sequence from the bottom up. What I find is very curious on this drawing is that there are no real dimensions showing me how to lay out the whole building. So right now I'm a little confused. I don't know how big this building is. I don't know really what's going on. I can see that it's probably a concrete foundation, but beyond that, it doesn't make a lot of sense to me quite yet. So I'm going to keep digging. I'm going to go to the next page here. You can see this says framing plan. So framing indicates that it's structural. So I might concentrate a lot down here on the titles of the pages. You can see right below here that these were issued for 100% construction documents, so I expect them to be complete. This has floor and low roof, so I'm looking at this saying, okay, some of these spaces here look like they're open, and some of them look like they might be floors, and some might be roofs. So I'm not quite sure what's going on. So let's go to the next page. Here's a high roof. Okay, so we've got a high roof and a low roof, and each of these lines is going to represent some sort of structural member. I'm not sure what the material is yet. I'm not sure if this is wood, if it's steel, if it's concrete. Not until I zoom in closely can I really tell that. Let's page to the next one. Now we're starting to get into the details. And typically structural drawings are organized in series, like 100s, 200s, 300s, etc. So here we can see the 300 series of the foundation details. That keeps that the foundation contractor organized in one spot. So I'm looking closely here, and as I start to page through here, I look and see that we have some typical details here with some concrete footings. So here we'll zoom in a little bit. We see a wall coming down on a little concrete stem wall and then a little concrete footing. And typically on structural drawings you'll get your how to build it in the details, but the dimensions will be on the plan. Also for here, bottom of footing, see general structural notes. So these there's a lot of abbreviations that are used that we'll have to go back to the first page to get. But this tells us the detail of how to build it. Okay. I'm going to jump back out here. We'll go to the next page and a couple more foundation details. Okay, so it's kind of a concrete, shallow foundation. I can see that we don't have deep drilled piers or caissons or anything, so that tells me a little bit about the building. Floor framing details. So now I look at this, I see a lot of things here that show how the walls and floors connect together. I'll just randomly pick one here. There's a detail. And what I'm seeing here are metal studs. So these are metal studs. I see concrete metal on a deck for the plan and a shelf angle here. So what I'm seeing are bearing walls built around the building, and a floor that's built of metal deck with concrete on top of it. So that's generally the construction of this building. And you can see the details are all very similar. So these are just the different ways that the floors and beams connect to the walls. We'll go to the next page here. A couple more framing details. This looks like I got some ways that the stairs are connecting together. Now we get up to the roof framing details. So I see a lot of slants here, which tells me there's going to be some complexity to this job. Just zoom into one here. Again, we have metal studs, bearing walls, and then we have joists. So I'm not sure quite what these joists are. I see plywood. I'm guessing that these are probably wood joists, and we can see a slope to it. So now I'm seeing this complexity of the building, that we have a sloped roof going on. And I go to the next drawing and I see more roof framing details. So these are all details, and each one of these details will be called out somewhere in plan. So for instance, I'm right now on sheet S501, and this detail right here is detail number 9. So somewhere in the drawings there's going to be a call out for detail 9 on S501. The last one here, a few more roof framing details. So it looks like it's not too complicated. So the first thing I want to do is get a feel for what the building looks like. So I'm going to switch over to the architectural drawing. And as I page through the architectural drawings, we usually start at the bottom. So the first drawings typically have to do with the site plan. So here's a site plan. It shows how the building is going to be oriented relative, and looks like some demolition, so what was existing here, and how this new building kind of in this area is oriented relative to different roads. Looks like some landscaping going on outside. Here I see a dimension plan. This is not very common to have a dimension plan, but because I believe of the all the circular elements to this building, it's important to have the dimensions here. So right now I'm seeing, okay, because the dimensions are all shown here on the architectural dimension plans, the structural engineer decided not to show them to make sure there was no confusion. That way there's only one source for dimensions. So this is where, unfortunately, the structural contractors, the foundation contractors, are going to have to come here to lay out their building. I see a few things here. I see all these dimensions. I see this point of beginning. So basically this is the reference point for the whole building. Everything's referenced to that point. The circles here, the circle in the middle, and these curved walls are identified by center points right here. So you can see this one right here, control point number 2. And so if we go over here, center point number 2, you can see that there's some dimensions given, and these dimensions are measured from that point of beginning. So to start the whole building, the contractor is going to have to figure out where this point is from the civil drawings, and then everything is referenced off that. So now we know where everything is in this building. Here's the roof and mezzanine second floor dimension plan, and then we get into the architectural plans. So right now I can see, okay, this looks like we've got a gathering space, we've got some study rooms, and we have some offices around on the first floor. We go up to the mezzanine, and what I'm seeing in this X here shows an opening. This looks like line of roof, so there's a cutting through a roof here. These cut lines here indicate that we're slicing through it. That's probably the slope of our roof. And then over here it looks like we've got a stair going up, a little elevator shaft, and then these are the details I was talking about. So let's zoom right in here. So what we see here are some details. Now these are architectural details, but if we're looking for a blow up of the elevator, we have detail 2 on A500, and this little dashed line around the outside indicates that that's a blow up plan. These little details and this symbol here shows elevations. So on A4.15 If we look at elevation number 4, it would be as if you were standing right here looking at that wall. Whereas if you were looking in this direction, you would see what you'd see in elevation number 5. So this gives me a feel for kind of how the building's laid out. I'm going to page to the next page here. This is where I see a roof plan, and what I'm seeing, if I zoom in here, are all these different slopes. So we can see that we have the roof sloping from an elevation of 26 to 23 to 22, and then this pops up. There's an elevator overrun here, so it pops up a little bit. So I see a valley. So I see a lot of complicated slopes here. So that's going to help me understand the structure by understanding the architecture. Let's see what else we can see from the architectural drawings here. If I jump to the elevations, we can see an elevation. So west elevation would be looking at the west side of the building. North elevation is looking at the north side of the building. So these are the directions that face west and north. And the architect has done a nice job of giving us an axonometric northwest. So this gives me a good feel. Okay, this building has curves and it has sloped roofs. There's that little elevator pop up where we're seeing punched windows. So I now have traversed the whole kind of set of drawings, and I have a feel for what's going on. There, it looked like back in this area by the elevator we had a little mezzanine. Otherwise, it's for the most part a single-story building, and that helps me understand the structure. So let's jump back to the structural drawings and take a little closer look. So I'm going to go back to the beginning, the general structural notes, and the general structural notes really give the detail about this type of building. There are specifications that will tell exactly how to build each part. However, the structural notes are different than most other trades where the specs take precedence. In structural drawings, typically it's the structural notes that take precedence over the specification. So let's jump in here, and by reading through the general notes, by skimming through them, we can get a good feel for a lot of the assumptions of this building and the materials. So let's just start off at the top here. I'm going to zoom into general. And first part is pretty much boilerplate. But as we move down, what we can see here is the building design criteria. So we know the building was done using the 2006 IBC. Typically on structural drawings, it's required to show all the loadings used for design. And this is because sometimes there's some items that are performance specified, such as curtain walls, that the contractors need to know what to design for. So this is all the information about the loads used in the building. Next thing we're going to go down to is see the soil bearing. So it should reference a soil investigation by who did it and the report number, and the minimum criteria for soil. So here it says that we have to put all the footings down 2'6" below adjacent finished floor or finished grade. So that keeps it below frost. Into engineered fill, there's the bearing capacity. So this tells me now if I'm going to build the footings, the shallowest I can go is 2.5 feet below grade. Materials and execution next. So we have concrete. We have concrete construction, and this tells me what the material properties should be for the concrete, aggregate size, etc. Most of this is pretty boilerplate, but this tells you where you notice that there's a difference. Unless otherwise noted, 4,000 psi concrete, but the fill on the metal deck is 3,000 psi. So that's good to know. Cast in place concrete gives us information about where the joint should be. Pretty standard. Reinforcing, this is standard. You really can't get any different types of steel. We'll go up to the next column. So a little bit more about the concrete and sandstone veneer notes. So I see, okay, there's going to be some structural sandstone. Looks like there's a fireplace going on. Then we have some structural steel. So we're mixing structural steel. We see ASTM designation. So this is the type of steel that's going to be used in the building. What to do about welding, what to do about bolting, minimum bolt sizes, adhesive anchors, headed studs, metal floor deck. So when they're buying the metal floor deck on the plans, it'll just say metal deck. Here it tells exactly how to install it. Structural steel framing. It says it's a non-self-supporting steel frame. That means the erector has to do some special things while erecting the building. Then we jump up here and we see cold form steel. So now we have a different type of steel. The other steel that we're looking is what they call rolled steel or red iron. Different terms are used. Cold form steel is basically sheet metal. It's metal studs and whatnot. So this particular building has a lot of metal studs and whatnot for the structural support. So you can see what materials are to be used, specifications for framing, and metal shear wall requirements. So there's shear walls made out of metal studs. Now I see the building has wood, so dimensional lumber, that's just 2x4s, 2x8s, etc. It has glue laminated beams, sheathing, which is basically plywood or OSB or something like that. Then we have shear walls on metal stud. We have plywood I-joists. Okay, so I see that those are like truss joists. So by going through the notes here, what I'm learning is the building is made up of a whole bunch of different materials. We've got wood, we've got metal studs, we've got concrete, and then we have structural steel. Let's jump up to the and we see here that this is still with the wood I-joists, and then the lag screws and connectors, and a little bit of information about shop drawings. So how the shop drawings, so this is information that the contractor will need to know about submitting shop drawings and preparing shop drawings. Special inspections that are required for this job. So there's the steel construction, the concrete construction, the plywood construction, and the soils. So there we have the general notes. And so by scanning through the general notes, I get a feel for what the materials are in the building, what the design parameters are, and what material specifications are needed for each one. The next thing I'm going to do is jump through the plans a little bit closer. So now I've already looked a little bit. I know that I'm going to have to go over to that architectural drawing to get my dimensions. But what I see here looks like we have some sort of bearing walls around the building, around the whole perimeter, sitting on concrete footings, and I'm seeing a lot of things here. Let's zoom into a corner and see what we can see. These little bubbles around things are revisions that were made with a little 1, so that ties it to something that was revised after the first issue of the drawing. Let's talk a little bit about lines on a foundation plan. When we have a dashed line, that indicates something that's beyond or hidden, like underneath the grade. So this line here is indicating these two lines are indicating the edge of the footing. You can see we have a square here, 3'6" square by 12" thick footing with 4 number 5 rebars each ways, typical of 3 places. Okay, so the engineer is getting a little lazy here. He pointed to one and says there's 3 of them. So I gotta go look somewhere else in the drawing. Looks like it's probably there's one and maybe that's the other one. Okay, so I'm assuming that those are made up the same way. What else do I see here? I see WF2. Well, WF I'm thinking maybe is wall footing number 2. And so whenever we see a tag like this, usually indicates that the information is found in a schedule somewhere. So I'll have to go to a schedule to find out what WF2 means. Over here I have SW4 and it's pointing to the wall. So our thick lines here are things that we're cutting through. So what I'm seeing here is a thick line indicating the bearing walls. SW4 is probably a shear wall. And then these letters A, B, C, and D probably tell me something about the plan notes. Cutting over a little bit here. Here's one of these details. So I could go and let's look at this one right here. It's detail 1 on sheet S300. And it's cut right through here looking in this direction. So let's jump to that sheet and see what we can find. So here's sheet S300, and we need to find detail 1. So zoom into detail 1 here. And here's detail 1. And so what we see here is that wall footing. So from above, this was a dashed line, and this was a dashed line here because this one's under soil and this one's underneath the slab. We had 3 lines on the top. Let me jump back and show you those 3 lines. So right here we've got the 2 dashed lines and then the 3 lines. So and it's the same, I think we were looking at this detail. So we have two lines widely spaced and 1 close by. So when we jump back to detail 1 on S300, what we're going to see is these 2 lines indicate the top of the wall, and that's a little bit of a ledge. Okay, like I said, when we were looking down, this was the outside line and these were the 2 top lines. So what we were looking down, we were cutting through the wall, and we were seeing this little bit of a ledge. The dashed line here indicates that it's the architectural exterior wall, and then here's the indication of the metal studs. 800S16254 just talks about the size of the stud. It's an 8-inch stud, the 1.62-inch flange on it, and then that has to do with the gauge of the stud. We space them 16-inch on center, unless otherwise noted. And this tells us a little track to put down, and then the specifications and notes will tell how to fasten them together. On structural concrete drawings, these heavy lines indicate rebar. The size of the hooks are usually not shown because those are standard per ACI specs. So a standard 90-degree hook is what the contractor would give there unless there's a dimension shown. A circle indicates a rebar that we're cutting through, so those are longitudinal ones. So you can see in this wall, you can see this line here. The contractor would come in and build the footing first with these pieces of rebar, and then these are called dowels that would stick out of that footing, and they come back and build the wall. So they'd form up the wall, put these rebar in it, and then they'd come back, do the slab, do the insulation, do the backfill, build the wall on top. So we build from the bottom up. Here it says see plan for size and reinforcement. So if we jump back to that plan, we'll know how to reinforce this particular one. So let's do that now. So we were looking at S300. So let's jump into this little area here. This tells me it's wall footing number 2 is running along here. So I'd have to find a schedule with wall footing number 2 on it. And what I see over here is the wall footing schedule. So let's jump over here. So wall footing 2, 2 feet wide, 12 inches thick. It has 2 number 5 bars continuous. Continuous means they put the bars in and they have to put lap splices, and again the distance in the lap splice will be told by the drawings, by the specifications. And then here it says typical unless noted otherwise. So if there's a footing that's not labeled on the drawing, the contractor knows use this one unless it's noted with one of these other indications. So now I have a good feel. There are little strip footings around the perimeter. Remember from the general notes they had to be 2'6" below the exterior grade or the finished slab. In this case the exterior grade was lower. So that tells the contractor how deep to go. You'll note on the drawings it didn't give any elevations, which puts a lot on the contractor to figure out. So we got those footings. We have these little spread footings here. Let's zoom into the middle and see what's going on. So I see this. I see this one here is looks like a footing. Here it's called out, a 4-foot square by 12-inch thick footing with 4 number 5s, each way typical of 4 places. Okay, so there's 1 of them, there's 2 of them, there's 3 of them, there's 4 of them. Here's a detail cutting through 1 of them, again on detail 3 on S300. And these round things are steel pipes. Again, there's no dimensions shown here, which is actually curious. We typically would show the dimensions on a structural plan, but this architect and engineer decided to show all the dimensions elsewhere. So the contractor is going to have to do a lot of work to figure out where these go. It's a 6-inch diameter, extra strong pipe column with a 3/4 inch square base plate, 4 J-bolts typical of 4 places. So we have 4 steel columns going up here, holding up probably the roof. We could jump over to S300 again and see what that detail looks like. Let's go to that detail 3 on S300. And this is what we just saw in plan. Talked about the footing. So that was the one we saw, the 4 foot by 4 foot plan. It gave the reinforcement in the plan. Here's our anchor bolts. It's reiterating what it said in plan, but it gives us our embed distance now. A little bit of how to actually build it, some dry pack grout. Typically on structural columns, we put the footing down at least a foot. On this drawing, it doesn't quite show where to put it. So we'd have to go back to the plan to see the elevation. But we put the footings down lower so that we can bury the base plate below the slab. Then the slab comes right and nice and neat up to the column. You have the column here. Detail 4 looks down at the base plate, so it shows how to lay the anchor bolts out. So let's go look at detail 4. Presume it's down here a little bit. So there's detail 4 looking down. We have the pipe column. This is a weld symbol showing how to weld the pipe to the plate. Here's our 4 anchor bolts, 1.25 inches from the edge. So I think I have enough information to build that column. So let's jump back out to the plan. So as an engineer trying to figure out the building, I would be going through all this, and I'd just go through it on a careful basis just to try to figure things out. So let's jump up to the framing plan and see what we have. I'm looking here, and what I'm seeing, let's take a zoom into this corner. What I'm seeing here is symbols for beams. So this is W10 by 12, which is an indication of a steel beam. It's a W shape, 10 inches deep, that weighs 12 pounds per foot. These are all details on the sheet 400 on how to connect things together. This is a little symbol showing how to build the floor. So when we show steel, we typically don't show the concrete. So it's as if you're looking through the concrete and you see the steel beams. We can see which beams support which beams by the gaps. So for instance, the first thing they would build is the column. Then this 10 by 26 would come in. They'd build the exterior wall, and then the 10 by 12s would frame across. So the gaps indicate where the different beams end. Over here, it's an indication of what the metal deck looks like. So it's almost like we've peeled away all the deck from everywhere and left a little piece of deck just to indicate that the deck spans this direction, and then concrete will be poured on top. Here's a note. It's 2.5 inches of normal weight concrete with some welded wire mesh fabric over 1.5 inch type B 22 gauge deck. 2.5 plus 1.5 gives a total structural thickness of 4. So we'll be laying that in. And so all these details pretty much show how everything comes together. I can see that this is a stair that goes down. We've got details exactly how to connect all the pieces of the stairs together. So this is a little area. It's a concrete and steel framed little mezzanine. Let's pan around a little bit. Let's go over here. Now what I'm seeing here, tongue and grid plywood per structural notes on 11 7/8 TJIs. So TJIs, we'd have to go back to the notes, but a TJI is a plywood I-beam. So now we have wood construction over here. So you can see, again, it's kind of cut away, but I see AHU1 3,300 pounds. So this looks like it's supporting an air handling unit. Double joist, just a little wood mezzanine. I walk around here, I see SL2. Well, I know that these are walls, so I'm thinking that's probably a steel lintel, and I'll find a schedule somewhere that talks about SL2s, and it should be titled steel lintels. Here we have 600S162 ceiling joists. So that tells me that these are metal studs by the designation. So we have a 14 by 22. We have some more ceiling joists over here. We have a little pipe column. 2-span continuous steel lintel rolled. Rolled means it's curved, so they actually bend the piece of steel around the radius. Again, around the radius. Go over here. Looks like we have some more metal stud joists. and tongue and groove over some 11, almost 12-inch TJIs. So this just looks like a little mezzanine plan here. So we got a bunch of different construction materials. We've got rolled structural steel with metal deck and concrete. We have wood TJIs or truss joists with plywood, and we have metal studs, and we have steel lintels. Okay, we'll jump over here. We'll look at these floor framing notes. It's always good to read the notes. A lot of good information there. So if we look at this, this tells us kind of where to go to get some information. Down here denotes steel header at openings. So L for lintel or header. So it just tells you what detail to go to. So a lot of times the general notes are going to cover very basic things that look like they're missing from the drawings. And we'll jump up to the roof here, and let's scan through the roof. And again, we're not going to figure out the whole drawing here, the whole building here, but we get a general feel for what's going on. So let's again start up in this corner here. These little arrow point out call outs tell us what the how to make connections, I'm guessing, and these are little details of how to make other connections. So I see 11 7/8 wood truss joists in this area being supported on a W21 by 50 steel beam. If we scan around here, we've got some roof area is plywood sheathing, and right here we have truss joists at 24-inch on center. Here we have a steel beam going across, is 21 by 50. C 3/4 inch means there's a 3/4 inch camber on the beam. It looks like this little symbol here looks like it stops, so it's a 21 by 44, runs over the column, and then there's a splice and another splice there, and then we have these 3/8 inch by 13.5 inch glue laminated beams going between here. So I'm looking at this. I know this is kind of a great room. I'm thinking, okay, architecturally they wanted to expose some wood on the underside. And we could go to the architect's drawings to confirm that. So if we remember what we saw from the three-dimensional drawing, so this is what the building looked like. We have these different structural roofs. We've got this roof that goes around that's sloping this way, and then we got this part that pops up that slopes this way. Looks like a little skylight and a little elevator shaft. And so by looking at that, I can see, okay, we've got all these different framing systems going on. So you can see this is an elevator shaft. Here's a little skylight. This is one roof sloping like this. And then we have this perimeter roof going around. So really there's a lot going on here. What I thought was useful by doing this little exercise is just to walk you through my thought process as a structural engineer when I go through a set of drawings, the things I look for and the things I go through. Thank you.